afternoon, everybody, and thank you for the invitation. I'm Valeria Ricotti, co-founder, CEO of Vesalic, and by training I'm a pediatric neurologist, and I promise I won't keep you long. I think we all deserve the aperitif now. And however, tonight with this talk, I would like to invite you to see neurodegenerative diseases through a different lens. Neurodegeneration is perhaps the greatest longevity and yet unresolved challenge. And neurodegenerative diseases are not that rare. 1 in 3 people will suffer from them. And the majority of them are sporadic in origin, so the root cause is unknown. And there are diseases such as Alzheimer's, Parkinson, and ALS are viewed as diseases of a specific neuronal population. Motor neuron for ALS, dopaminergic neurons for PD, and certain cortical circuit for AD. However, there is an emerging evidence that the pathology actually happens beyond the brain. Yet, most diagnostic biomarkers and therapeutic targets are actually targeting the end-loss neuronal damage, the site where the neuronal damage occurs, rather than upstream causes. The major challenge in neurodegenerative diseases is timing, because once the clinical symptoms occur, the neuronal loss has already occurred over many years. And this is where current biomarkers actually fail, because they identify the end-stage neuronal loss, but this has been occurring for many years before. So if we're able to diagnose this disease during the silent biological phase, then we have an opportunity to intervene and change the course of the disease. This is a publication from this year, from our collaborators at Imperial College, which shows that in diseases such as Alzheimer's, vascular dementia, there are comorbidities that occur many years before the clinical onset, in some cases even up to 20 years. And these comorbidities differ for AD and vascular dementia. But what it shows is that there is a prolonged systemic phase which precedes the overt neurological symptoms. And this is not an isolated publication. There is a growing body of evidence showing that neurodegeneration is a systems level disorder. So there is evidence involving metabolic dysfunction, immune signaling, and intercellular communication. And these all support the idea of a biology model of neurodegeneration across different organs and tissue. And that should not come as a surprise, considering that aging itself is systemic. And perhaps what we want to say here is that neurodegeneration represents one of the most visible manifestations of this systemic biological dysregulation and aging. So how these distant organs are biologically interconnected? How do they communicate? And the answer probably lies with extracellular vesicles, EVs. These are nanoscale vesicles that are released by virtually every cell and every organ in the body. They have a very rich membrane made of proteins and lipids, and they carry proteins, lipids, RNA. They act as biological messengers between cells and distant organs. They're a bit like an email system of our body. And we know that they're not just messengers and biomarkers, but they're also active mediators of the aging-related biological process. So what we did at Vesalic, from a small sample, blood sample, we isolated the exosomes, and we characterized the lipids of the membrane of these exosomes using mass spectroscopy. Why lipids? Because we know these are not passive structures, but they have a role in signaling and in metabolism. And because we're looking at over 140 lipids, this is a multi-level signature that we are characterizing. We use AI modeling. And this helped us to classify and give a predictive risk of, from these subjects in terms of disease classification. And this is representing the accuracy of our biomarker in the context of ALS. We have an accuracy of 94% with a sensitivity and specificity that approaches 100%. And I want to highlight that this is both for sporadic and monogenic motor neuron disease. So this covers all spectrum. And we can see that there is a handful of patients that are classified as healthy. And when we go back to the clinicians who provide the samples to us, they confirm that these are very atypical ALS, and probably they are a different subset of patients altogether. And equally, there are a couple of patients a couple of healthy subjects that are classified as ALS. And perhaps this biomarker is indeed capturing the silent biological phase of the condition, and down the line they may develop the disease. So we'll follow them up closely. This is not a single signature. As I said, we looked at 140 lipids, and we applied AI-driven feature ranking and predictive modeling to identify those lipids that are actually more meaningful in diagnosing the disease. Which are about 15. But essentially, this is a coordinated multi-lipid signature that is underlying the disease classification. And again, this is not surprising, as neurodegeneration and aging is a very complex biological phenomenon. Our platform has been deployed also to other conditions besides ALS, including Alzheimer's and Parkinson. We're studying other neurodegenerative and degenerative diseases as well. So this is a signature that is diagnostic. We believe from preliminary data that it's also predictive, so it's able to identify those subjects at risk of developing the condition. And we have also preliminary data in patients with ALS treated with an antisense oligomer that our marker is responsive to therapy if the root cause of the disease is treated. But beyond being messengers and biomarkers, EVs can also be therapeutic targets. We know that they carry a pathological cargo, and in cancer therapy there have been therapeutic targets for many years. And in neurodegenerative diseases, we know that EVs can carry toxic proteins such as tau, beta amyloid, SOD1, and they do cross the blood-brain barrier, so they may contribute to the spread of the pathology into the central nervous system. So what we did, we exposed motor neuron from healthy subjects to exosomes derived from ALS patients, PD patients, and then healthy subjects. And what we show here is that those motor neurons in vitro die in ALS and in PD, but they do not die when exposed to healthy EVs. So essentially our approach is a dual approach. We have a platform capable from a small blood sample to detect the disease and by characterizing the lipid membrane of these exosomes. But we've also developed a monoclonal antibody that targets those exosomes that have a toxic cargo, and we prevent them at a bloodstream level. We intercept them and we prevent them from reaching the central nervous system and therefore exploit the toxicity cargo into the CNS. So our therapeutic lead candidate is a monoclonal antibody that in vitro has shown to neutralize this toxicity of the EVs, and our goal, our aim is to block the upstream toxicity signaling before any reversible neuronal damage can occur in this motor neuron disease. We have just completed a proof of concept study in animal models, which showed very encouraging results, and we're in the process of analyzing the histopathology. And needless to say that if this approach works for motor neuron, of course with a different targeting, we potentially can also roll it into other neurodegenerative conditions such as PD and AD. So the take-home message is that neurodegenerative may reflect a broader systemic aging process rather than just an isolated CNS pathology. And Vesalic provides perhaps evidence of a systemic metabolic dysfunction that occurs in motor neuron, in AD and PD. And this underlying pathogenic process is identical in sporadic and monogenic ALS involving EV toxicity. And there is an emerging evidence suggesting that biological dysregulation may precede clinical disease by years, even decades before the symptoms occur. So this creates the unique opportunity for earlier detection of these diseases and intervention before irreversible neurodegeneration occurs. So all this work would have not been possible if it wasn't for all our outstanding collaborators, some here in Italy, Milan, in Ferrara, and our UK colleagues from UCL, Imperial College, and Sheffield University. Thank you very much for your attention.